Again, welcome to College Algebra. Today, our main topic is applications of linear equations. We covered linear equations already, and we said linear equations are normally equations that the variable exponent, the highest variable exponent is 1. So when we plot a graph of a linear equation, we get a straight line. So today, we're going to discuss about some few applications of linear equation, which means solving problems. So we are going to solve normal problems. Example, solving geometric problem, only one problem, solving investment and percent problem, break-even analysis problem. All these problems, we are using the linear equation concept to solve all these problems. So let's dive through it. Here we say the application of linear equations, the process of finding the equation that describe the words of the problem is called mathematical modeling. We have this in statistics, even data mining, data science. Always we want to come up with a modeling. Example would be a regression analysis or regression model or classification model. We come with a mathematical modeling that may solve a problem. So strategy for modeling equation. First, of course, we have to understand our problem, the problem that we want to solve. So we have to analyze the problem to see what you are to find. Often we look at what should be the input to the problem, what should be the output. Then we come up with the modeling to design the process of transforming the input to output. So often we draw a diagram. Drawing a diagram is very good because it makes us to understand the problem more and also get the main concept of the whole problem. Or marking a table with the help, you can visualize the facts. Then next, we pick a variable to represent the quantity that is to be found. A variable means it can be any answer. So let's pick a variable x or y, and x and y can be any value, but that will represent what we are looking for. Then based on the question, we are going to write a sentence telling what the variable represents. Then we express all other quantities mentioned in the problem as expression involving this single variable. So based on the condition. Now, let's dive into solving the problems now. So again, find a way to express a quantity in two different ways and also form an equation indicating the two quantities found in step 3. Then we solve the equation. Answer the question asked in the problem and then check the answers in the words of the problem. These are the 7 steps, but I think the best way to practice mathematics is by solving problems. So let's get into our solving our normal problems. So your question is given to us. They said a student has scores of 74, 78, and 70 on 3 music theory exams. So we have a student that scored 3 different scores in a 3 exams. Now, here the question says, what score is needed on the 4th exam for the student to earn average grade of 80? So now the first thing we need to do is understand this problem. Understanding this problem will help us to solve this question easily, but our goal here is to come up with a modeling. Now we know that we are looking for a 4th exam, and when we get the 4th exam score, all the 4 scores will give us the average of 80. So our modeling here will be finding the average of a number, finding the average of at least 4 numbers here, 4 scores. So you can see here we represent X, that's what we are looking for, the 4th exam score. And we know that the average grade will be 1/4 of the sum of the 4th grade, because we know already average of numbers will be the sum of all the numbers divided by the number of values we have. So here we have 4 values, which means we have to sum all the 4 values that we divide by 4. That's why we are saying that the average grade will be 1/4 of the sum of all the 4 grades, because we had all the 4 values we divide by 4. So the modeling here will be 74 plus 78 plus 70 plus x equal to 4. And this is the average. and the answer will be 80. So our goal is to find the fourth score, which is the x. Since the question already gave us the value for the average of all the four scores, which is 80. And the three scores are 74, 78, and 70. So here we had everything. We get 222 plus x over 480. We cross multiply. Then we get 4 times 80 will give me 320. So I get 222 plus x, 320. Now we know that we solved this problem already when we are doing linear equation. When I'm adding, when I cross the equal sign, I'm going to do what? Subtract. When I'm dividing, when I cross the equal sign, I'm going to multiply. So that's why we multiply. 4 is dividing on my left side. So when it crosses the equal sign, it's going to multiply by 80. 222 is adding to x. So when it crosses the equal sign, it's going to subtract from 320. So our final answer will be S will be 98. So this means for the student to earn an average of 80, the student must score 98 on the fourth exam. So let's go to another problem here, solving geometric problems. So here we have a question. They said a city ordinance requires a man to install a fence around the swimming pool, as shown in figure 1-2. So here we can see the swimming pool size is 20 by 16. But we need some fence around the swimming pool, and the distance of the fence is x. So here now they are telling us he wants to border around the pool to be uniform width. So the distance between all the four sides will be the same, uniform width. Now, if he has 154 feet of fencing, find the width of the border. So the question here is that we have a swimming pool, the size is 16 by 24. We want to fence the whole swimming pool, but we have only 154 feet of fencing. So what will be the equal width for all the four sides to take 154? Because, for example, if the x value is getting bigger, that means the fencing will be larger. If it gets smaller, if s is smaller, then the total fencing will be smaller. So that's our goal here. We'll have 154 feet of fencing. We should find the width of the border. Now, all the four sides, the width are the same. So this is a very straightforward question. Now, we also said that let S represent the width of the border because that's what we are looking for. Now, the distance around the large rectangle called its parameter. So now, let's go back to the question more, the diagram. So this tells me that if it has 154 feet of fencing, then the parameter will be 154 because parameter is all the four sides. The measurement of the total measurement of all the four sides is called parameter. So here we say the parameter is 2L plus 2W, which makes sense here because how many length we have? 1 and 2. How many width? 1 and 2. So the parameter will be, I would say the width plus length plus length. So we can say 2 width plus 2 length. And that's what we have the model here, where L is the length. And this time they say the length is 20 plus 2x. W is the width, 16. Why is it 16 plus 2x? Let's go back again to the diagram. Now, I have the length here for the swimming pool. I know it is 20 feet. But from the right side is x, the left side is x. So I have to add 20 plus x, so it's 20 plus 2x. The same thing, I have the width here, 16 feet. We have x at the top, x at the down. So it will be 16 plus x, which is 16 plus 2x. So from the diagram, we can get the total. So we have both the length and the width of the fence. So here we have to write it down. The parameter, which is the total fencing, is 154. We know the formula for a parameter will be the 2 times the length plus 2 times the width, because we have 2 lengths and 2 widths. Now we know the length of the fence will be 20 plus 2x. Then we know the width of the fence will be 16 plus 2x from the diagram. So our goal now is to substitute. So we open the parentheses, we get 154 equal to 40 plus 4x plus 32 plus 4x. We combine the like terms, so we have 4x plus 4x will give me 8x. 40 plus 32 will give me 72. So now we have 154 equal to 72 plus 8x. But since 72 is hardy, when you cross the equal sign to the left, it's going to subtract. So when we subtract 72 from 154, we get 82. So we get 82 equal to 8x. Now 8 is multiply. So when you cross the equal sign, it's going to divide. So 82 divided by 8 will give me 10 by 1/4 or 10.25. So which means the width of all the border, the four borders should be 10.25 or 10 by 1/4. So you can see that the two examples we have solved so far, we have to use the formula. The first question is the condition based on the question is finding the average. We have the first value, second value, third value of scores. What will be the fourth value that the average will give us? 80. So we wrote the formula of average and solve it. Here, this is a geometry problem. We have a swimming pool. The size is 20 by 16. We need a fence around the swimming pool, but our total fence, which is the parameter, the measurement, is 154. So since we know that a parameter 154 is the length times the length plus the width times the width, because we have two lengths and two widths, 4 sides. Then we plug in the values and we came up with a solution. Now let's go to our third problem. Here we are solving investment and also percent problems. So our question said Laurie invested $10,000, part as 9%, and the rest at 14%. So we have part $10,000 was invested. Part of it will give us 9% interest, and the rest at 14%. If the annual income from this investment is $1,275, which means the total interest we get from the investment is $1,275, how much did she invest at each rate? So I have $10,000. I invested some part of the amount, which is what we are going to look for. And that part gave me only 9% interest. The rest of the amount gave me 14% interest. But by the end of the year, I had $1,275 interest in. Now we want to know how much we invested in 9% and how much we invested for the 14%. This is what we are looking for. So in this case, I'm going to represent X as the amount invested at 9%. So S is the amount I invested at 9%. Then the rest. So the rest that I invested for 40% will be what? 10,000 minus X. So here we say then 10,000 minus X represent the amount invested at 14%. When we read beginning of the problem, they say one main thing we have to do, always represent the variable as the value that you are, whatever you are looking, represent it as a variable. And that's what we are doing here. We are looking for first 9%, how much we invested. So we represent that by X. And they say the rest will be 14%. So 10,000 minus X will be the 14%. Now, since we have this down, since the annual income from the investment is the product of the interest rate and the amount invested, we have the following information. Annual interest, the $1,275 means $10,000 times the interest that I earn. But here we have two different interests, so this is what makes the problem a little bit, I won't say difficult, but a little bit more detailed. Now, if my interest is only one, then this is easy problem because my interest will be $1,275. What I earn is equal to my product times the rate. So I'll find the rate. The rate will be what? The interest earned divided by the amount that I invested. But here we have two different investments. So we have the table here saying that 9%, which is the same as 0.09, is the amount invested was X. So we know that it will be what? 0 times 0.9x will give us the interest N. If I invested $10,000, the interest N will be the rate times the $10,000. So right now we don't know, so we will present it at X. If that's the case, then the 14% investment, which is 0.14, is 10,000 minus the X, as we said earlier. So the interest that I earn of 14% will be 0.14, 10,000 minus X. Okay, so if I know these two, I'll solve my problem now. I know my total interest. So my total interest will equal to what? The first interest of 0.09 plus the second interest of 0.14 or 14%. Then here S will be common. We find the value of X. And that's what we have here. So the income from the 9% will be 0.09X plus the income from the 14% investment, which is 0.14 times 10,000 minus X. Total interest of the two will give me 1275, which was given to us. So we solve this problem. We open the parentheses first, and this is what we get. And then we add the like terms together, minus 14x plus 9x will give me minus 5x. 140,000 is adding, so it's going to subtract on the left side. So we get minus 5x equal to minus 12,500. Minus 5x is multiplied by x. So when you cross the equal sign, it's going to divide. Then that will give us 2,500. Again, I'm skipping the steps here, some of the steps here. The reason why we already went through linear equations already. How we solve linear equations. Here, how do we solve applications of linear equations? So setting up the linear equation, for example, this part is what we are learning now. So hopefully this is okay. So let's move to next question. Okay, we haven't finished yet. So we know 9% is 2,500. So if 9% is 2,500, 14% will be 7,500. We have that in our equation already. Okay, so now we're going to solve the next question, which is the break-even point analysis problem. This is more economics problem. So yes, they say running a machine involving two costs. We have a setup cost, we have a unit cost. Setup costs include the cost of installing a machine and also preparing it to do a job. Unit cost is the cost to manufacture each item, which include the cost of material and also labor. If there are two machines to do a job, the break point is the number of units manufactured at which the cost on each machine is the same. So the unit point normally is where the revenue equal to the total expenses. There's no profit, there's no loss. Yeah, that was an ambulance, again, living in New York City. And this is one of the interruptions. So I'll pause the video for a few seconds or a minute for the ambulance to go away. So I'll go through this again. Running a machine, here they say it's involving two costs. We have a setup costs and a unit cost. And sometimes we may say the setup cost is the same as a fixed cost. And the setup costs include the cost of installing the machine, preparing it to do a job, maybe including the lease or rent of the facility, etc. And then the unit cost will be how much it costs to produce each item. So now we have a question. Suppose that one machine has a setup cost of $400 and also a unit cost of $1.50. That's per a product. And also a second machine has a setup cost of $500 and the unit cost is $1.25. Here they say we should find a breakpoint. Our breakpoint is that we want to find the even for both machines. So first, I'm going to find the total cost for the first machine. It will be our setup cost or the fixed cost plus what? The variable cost, which we call the unit cost. Normally, we use the term the fixed cost plus the variable cost or the overhead cost will give us the total cost. So here we say the setup cost is 400 plus 1.5x. That is for each product. X depends on how many products that we produce or manufactured. For example, if we manufacture 100 products, then we get like $150 expenses. If it's $200, $300. If it's only one product, then we spend only $1.50. But the 400 is constant. That's why we use the term fixed cost also. The second machine, the setup cost is 500. Unit cost is 1.25. Our goal is to find a breakpoint. Breakpoint means equal. So our goal is that how many X's, how many units we are going to produce. That will give us a breakpoint. So here, equal. The first machine equal to the second machine. Then we are looking for the value of X. So here we set up our linear equation, which will be 400 plus 1.5x equal to 500 plus 1.25x. Again, break-even point or break point means where two conditions are equal. First machine and second machine are equal. So how many products that we are going to produce so that the first machine and second machine costs will be the same. So from here going, we are using the linear equation techniques. 500 is here. I'll take the 400 from the left side to the right side is going to be minus. I may take 1.25 to the left side is going to be subtraction. So this is what we get. 0.25s equal to 100. So S will give me 400. So this means the break point is producing 400 units. This result is correct because it will cost the same amount to manufacture 400 units with either machine. So whether I use machine 1 or machine 2, if I produce 400 items, their cost is the same. So the concept of break point or break-even point is sometimes we do this with revenue and costs. So if I have a company producing something, my total cost is 100. My revenue I produced in that very unit was 100. Then I have a break-even point because the total cost is the same as the total revenue. So there's no profit, there's no loss. Let's go to a fifth one. So here, solving share work problems. So here we say a tollway authority needs to pave 100 miles of interstate highway before freezing temperature come in about 60 days. So Jostrom and Sons has estimated that it can do the job in 110 days. Scandrolin and Sons has estimated that it can do the job in 140 days. If the authority hires both contractors, will the job get done in time? So here our goal is that we have two contractors. One gave us 110 days, he can finish the job. The second gave us 140 days. We are not about the cost of the project, but how long it will take. So here we say since S. Jostrom can do the job in 110 days, it can do 1 by 1/10 of the job in 1 day. 1 by 1/10 of the job in 1 day. And since Scandrola can do the job in 140 days, it can also do 1 by 140 of the job in 1 day. So here, we let N represent the number of days because that's what we are looking for. And it will take to pave the highway, if both contractors work together, they can do 1N of the job in 1 day. Now, the work that they can do together in one day is the sum of each can do in one day. So just from is 110 days, so it's 1 over 110 plus the second contractor is 440 days, so 1 day will be 1 over 40. Then we say let 1 over n represent 1 day. So this is our equation here. So the part that give the pave together in 1 day, so both of them together, we had them together, is 1 over n. Our goal is to look for the value of n. So we do our arithmetic operations and we get n equal to 61.6. So it will take the contractors almost 62 days to pave the highway together. So if we hire both contractors. Now, the simple way we can understand this is that if, for example, the first contractor said 100 days, the second contractor also said 100 days, then if we hired both contractors together, it will take what? 55 days to finish because they will double the work. So instead of 110. So the same concept is here. How did I get the 55 days? Because I divided 110 by what? 2, because 2 contractors. So it's like half times 110. But here, since we have 2 different days, 110 and 140, we represent 1 over total, n will be the total days. So 1 day will be 1 over n. And we are looking for 1 over n for each day. So by doing this, at the end, n will give us 61.6, roughly 62 days. So our last question is solving a mixture problems. And so here we have a container. It's partially filled with 20 liters of a whole milk containing 4% butter fat. How much 1% milk must be added to obtain a mixture that is 2% butter fat? So here we are missing, since the first container contained 20 liters of 4% milk, it will contain, again, 0.04 times 20 liters of butter fat. So to this amount, we will add the content of the second container, which also holds what? 0.01 liters of butter fat. Because how much 1% must be added to obtain a mixture that is 2%. So we don't know the liter yet, so we represent it as L. Now the sum of these two amounts will equal the number of liters of butter fat in the third container, which is what? 0.02, 20 plus N liters of the butter fat. So now we know the butter fat in the 4% was straightforward, 4% of 20 liters. Plus the butter fat in this 1%, we don't know how many liters, so we say 1% of N liters. It will equal to butter fat in the 2% milk, which will be 2% of 20 plus what? L. Add them together. So here we get the equation. The first one is straightforward, 0.04 times 4% is 0.04. The liters is 20. 1% is 0.01 times L. So when we have 20 plus L, we get 0.02, 20 plus L. Then we solve our equation. So when we solve, we get L to the 40. So this means the answer will be 40. So to dilute the 20 liters of 4% milk to 2% mixture, 40 liters of 1% milk must be added. Now to check, we know that final mixture contains 0.02 times 60, which will give me 1.2 liters of pure butter fat. And this is equal to amount of pure butter fat in 4% milk and also 1% milk. So this will give me 0.0420. And when we find the 40 liters for 1%, so 0.04 times. So this will give us 1.2 liters. So this will be, again, the conclusion of linear equation application. So here we already studied the linear equations, but we want to give one example where we normally can apply linear equations. So again, here we studied about the linear equation application. We saw mixture of problems, average, finance, accounting, and it can even be applied in economics like break-even point, etc. So wish everybody the best. Thank you.